So today we discuss about system of linear equations. Consider the system of linear equations. A11 into x1 plus A12 into x2 plus A13 into x3 plus A1n into xn, which is equal to b1. Similarly, A21 into x1 plus A22 into x2 plus A23 into x3 up to A2n into xn is equal to b2. This is the second equation. Similarly, A31 into x1 plus A32 into x2 plus A33 into x3 up to A3n into xn, which is equal to b3. Similarly, we can write down, this is the first row, first equation, second equation, third equation. So let me write down the mth equation, which is am1 into x1 plus am2 into x2 plus am3 into x3 up to amn into xn, which is equal to bm. So here, the total number of variables is x1, x2, x3 up to xn. So total number of variable is xn, and total number of equations. How many equations we have? So 1, 2, 3, 4, 5, and so on. So we have m equations. So n number of variables and m number of equations. So this is called system of linear equations. Why it is called linear equations? Because here the x1, x2, x3, and xn, these are the variable and whose maximum power is 1, means linear. Therefore, it is called linear equations. And now, since we are consider not only one equations, but we are considering about the system of linear equations. So this is called system of linear equations. So now, this system of linear equations can be written as in the matrix form Ax is equal to B, where what is A? A is equal to all the coefficients of variable like that A11, A12, A13, A11. This is the first row. Similarly, A21, A22, A23, A2n. This is the second row. And A31, A32, A33, A3n is the third row. And similarly, we are able to write down the last m rows, which is AM1, AM2, AM3, and AMn. And then we can write down what is the value, what is it, this x? This x is called x1, x2, x3, which is also called the variable matrix. And the last column, this B is nothing but the collection of all the coefficients, or we can say that the constant of the given equation. So B1, B2, B3, and Bm. So this is called the system of linear equations in the form of matrices. So out of these three matrices, the first matrix A, which is called the coefficient matrix. Why it is called coefficient matrix? Because this matrix is obtained by collecting all the coefficients of the variable x1, x2, x3, and xn. The second matrix is called variable matrix because it contains all variables. And the third matrix is called constant matrix because it is the matrix which contains all the constants. Here, A is called coefficient matrix, X is called variable matrix, and B is called constant matrix. Now there is one more matrix which is called augmented matrix. So if Ax is equal to B, be a system of m linear equations with n unknowns, then augmented matrix is denoted by A colon B and is defined by A colon B is equal to A11, A12, A1n So this first part is what? It is nothing but the coefficient matrix. And the second part is the constant matrix. So if we combine the coefficient matrix and constant matrix, then this matrix is called augmented matrix. Okay, we will see that what is the use of this augmented matrix, or what is the need of define the augmented matrix. Now, the second thing is the system of non-homogeneous linear equations. So a system of m linear equations with n unknowns ax is equal to b is called system of non-homogeneous linear equations if b is not equal to 0. This b constant metric, this b constant metric is not 0, then this system is called non-homogeneous linear equations. And if it is 0, then what will happen? If this b is 0, then the system is called system of homogeneous linear equations. So system of m linear equations with n unknowns, ax is equal to b is called system of homogeneous linear equations if b is equal to 0. Condition for consistency of non-homogeneous equations. So let ax is equal to b be a system of m non-homogeneous linear equations with n unknowns, then m is equal to total number of equations and n is total number of unknowns. And row of A, which is called a rank of coefficient matrix, row of AB is called the rank of augmented matrix. So let us define what is the meaning of consistency. So the point number 1, if rank of A is equal to rank of augmented matrix, then the system of equations is consistent and hence the given system of equation have solutions. Rank of A is equal to rank of augmented matrix, then the system is called consistent and it has some solutions. So now we will get the two solutions. The first is called unique solution, or it is also called only one solution. So if rank of A, which is equal to rank of augmented matrix, which is equal to number of variables, then the system have unique solution. And the second part is infinitely many solutions. So if rank of A is equal to rank of augmented matrix, which is less than n number of variables, then the system of equations have infinitely many solutions. So these are two solutions if the given equations are consistent. The first is called unique solution or only one solution, and the second one is called infinitely many solutions. The condition are that what are the conditions for that? Rank of A should be always equal to rank of augmented matrix. B, the system is consistent, and if the number of variable is also same, then we get the unique solution. But if the rank of A and augmented matrix both are same and which is less than number of variable, then we say that the system have infinitely many solutions. And the second condition, if rank of A is not equal to rank of augmented matrix, then the system of equation is not consistent and hence the given system of equations have no solution. So let us try to draw or take the geometrical representation of these three type of solutions. So let us given a different equations. So this is the first equation, second equation, third equation, fourth equation. So just look here, all four equations are intersecting only at one point. So lines are intersecting at one point. So this is called unique solution or only one solution. So what are the equations we have given? All equations will intersect only at one point. So we can get the unique solution. The second point is what? We have the first equation. The second equation is also overlapped to that equation. Third equation is also overlapped. and fourth equations are also overlapped to the same equation, same line. So what are the equations we have given? If all equations are overlapped to each other, so at that time, we get infinitely many solutions, means each and every point of the on the given line are the solution of the system of linear equations. The third is what? Let us the first equation. The second equation is parallel to the first equation. Third equation is also parallel to both the first and second equation. Fourth equation is also parallel to the remaining three equations. So now if we have given such type of parallel equations, then we say that the lines are parallel to each other. And at that time, we don't get any solutions, or we can say that no solutions. So now if lines are intersecting at only one point, we get unique solution. If lines are overlapping to each other, we get infinitely many solutions. And if lines are parallel to each other, we don't have any solutions. So this can be also described into the form of pictures like non-homogeneous system Ax equal to B, where n is the unknown. So there are two varieties of this form. The first one is called consistent. If rank of A is equal to rank of augmented matrix, which is equal to the number of variable, it should be n, number of unknown quantity. Let us consider rank of A is equal to rank of augmented matrix is equal to R. And the second thing is what? Rank of A is not equal to rank of augmented matrix. So if they are equal, then we say that it is consistent. If then they are not equal, then we say that it is not consistent or inconsistent. Again, if the system is not consistent, then we don't have any solutions. So the system has no solution. And now, if the system is consistent, then we have two situations. The first situation, unique solution, if the value of n and the rank of A and augmented matrix both are same, at that time we get the unique solution. And similarly, if we have the second condition, a rank of A and rank of augmented matrix, which is R, and which is always less than the number of unknown variable, then we say that the system has infinitely many solutions. So this is what we can say, that it is the one slide we are able to describe the system of homogeneous equations, non-homogeneous equations, and when we get its solution, when it will be consistent, when it will not be the consistent, and if it is consistent, then we get unique solution, or infinitely many solutions, or no solutions. So lines are intersecting at one point in the first part. The second part, lines are overlapping to each other. And the third part, lines are parallel to each other. So in the next lecture, we take one example and discuss about how we are able to get the unique solution, infinitely many solutions, and no solutions of the system of linear equations. So thank you, everyone.